Now let's talk about a ball rolling down a ramp. Okay, the ball is here at, let's say t equals 0, right? And let's say that the pendulum you were using, or the seconds you were counting, depending on what you were doing, let's say your count or your pendulum period was 0.8 seconds. So here's a ball t equals 0. Here it is at 0.8 seconds, right? And since you were counting equal intervals, the next time would be what? 1.6 seconds, right? So down here somewhere, we have t equals 1.6 second position. And let's just say that on your meter stick is supposed to be parallel to the ramp, but it isn't. Okay, here's your meter stick, and the position on your meter stick here, and the position on your meter stick here is, let's say, 12 centimeters and 53 centimeters. Okay? That's something you could have observed in what we just did. Okay, so the rate of change of quantity A with respect to some quantity B is, and this is an average rate of change, it's change in A divided by change in B. Okay? So what is the average rate of change of position I'm going to use WRT to stand for with respect to time. So, if the average rate of change of A with respect to B is change in A divided by change in B, what's the average rate of change of position with respect to time? Ignore the numbers here, just what do we mean by the average rate of change of position with respect to time? By the definition, what does the definition tell us the average rate is? Well, it's change in something divided by change in something else, right? What's this something and what's this something?
A over 16 or 16 over A.
I'm sorry, again?
16 over...
Okay, let's not talk about the numbers yet. Let's just talk about words. I've got some words here that are the same as the words I had up here, right? Mm-hmm. But most of the words are the same. What words are different? Well, if you read this statement, average rate of change of position with respect to time, what don't you see from up here? Do you see A?
No.
Is A in here anywhere?
Position.
Is B in here anywhere? Is there something here in place of A?
Yes.
So
What is it?
position over time?
Okay. No, not changing position over time, but I know what you mean. Change in position over change in time.
Time, that's what I meant.
I'm sorry.
I know that's what you meant to say. I said I knew what you meant.
No.
Okay? Good. Right?
Yeah.
Now, do we understand what I just did?
Yeah.
Through the magic of identifying how this thing is not the same as the other, which we learned from Sesame Street, we can see that they're not the same because I have A here where I have position here, and I have B here where I have time here. Right?
Yeah.
Okay? Everybody understand what I just said? It's very fundamental, but it's something that doesn't necessarily occur to you because it's not the kind of thing you've frequently been asked to do, is it?
No.
So it's kind of new. That's fine. That's why.
You will have 15 minutes right now. Or you got like...
No, I'm at 5 minutes and 53 seconds.
Oh.
But it was 15 minutes since I started. But since I started this, yeah, I stopped that clip and started another one. So I'm only 5 minutes into it.
Okay.
So if you see another 8 minutes, warn me. But we'll probably be done.
Okay.
But thank you. I'm glad you're keeping track of that. Now, okay, so we have change in position divided by change in time, right? So, now I'm getting more and more abbreviated because I don't want to waste a lot of time writing out a lot of long words, although rate of change isn't that long, but ROC stands for rate of change, okay? So this is the average rate of change of position with respect to time between t equals 0 and t equals 0.8 seconds. Okay? Now what do we mean by that?
Well, I mean...
Well, yeah, go
Oh,
ahead.
I'm sorry. Well, I mean, would you find the average of them? So it'd be like change in time would be 0.8, and then the change in position would be from 0 to 12. So it'd be 12 over 0.8.
Yeah, but that's not an average.
So it'd be...
You just found the change in
Point.
position and the change in time, right?
Yeah, it'd be 6 over 0.4.
No. No. Change in position is
It's 12.
12 centimeters, right?
Yeah.
So change in position is 12 centimeters. That's a change in position between 0, well, between this end of the meter stick, which we assume is lined up here, so here's 0, right? And 12 centimeters. So the position changed by 12 centimeters, didn't it? Okay? Over 0.8 seconds, right? And what do you get if you divide 12 centimeters by 0.8 seconds? Well, you're going to get 15 is going to be your number. What else are you going to get?
Centimeters per second?
Yeah, centimeters over seconds, which is centimeters per second. Okay? So that's how fast you're moving, isn't it? Okay? Okay, so I'm going to stop this clip. I'm going to give you a minute to figure this out. We don't want a lot of dead space in the clip. I mean, I could sing and dance while you're figuring this out, but that would be worse than dead space. So I'm going to stop the clip, and then we'll pick it up in a minute after you've figured out the next change in position and change in clock time. In other words, for this interval between here and here, right?
Yeah.
What is your average rate?